Okay, so now I'm going to kind of extend what my partner was saying, and we'll also talk about some implied consequences of the affirmative side. First, we were talking about how costly hydrogen is to create. This is from David Morris, who wrote Hydrogen Economy is a Bad Idea. Today, the cheapest source of hydrogen is natural gas, which is both an energy source and a hydrogen source. The problem is that the resulting hydrogen is only 50% of the chemical energy of the original gas. So as we're creating hydrogen, we're also losing half of the energy that we had from the energy source to begin with. Hydrogen can also be produced from oil, but the efficiency is a little worse. The hydrogen is derived from fossil fuels, carbon dioxide, greenhouse gases released in all cases. Basically, what that means is that even though we have abundant sources like gas and natural gas and all those, they don't solve the emissions problem. That means we have to do something else. And really, the only other thing we can do is electrolysis. And we have an issue with that. Let's take a look at the efficiency of an electric car. So that means we're not running off of gas, it's all electricity, whether you're using a fuel cell, which creates electricity from hydrogen, or if you're using a battery-powered car. If we look at the whole cycle, the efficiency of an electric car is 72%, and that's conversion from electrical energy to mechanical. 40% for the power plant, so that's conversion from whatever fuel you're using into electricity. 90% for charging the car, so charging up the batteries, what have you, which gives the overall efficiency of only 26%. If a hydroelectric power plant is used, efficiency of the electric car jumps up to about 65%. So what that shows is that the only way that this is viable is if we can use a source that's not a fossil fuel. So, in reference to the claim about where the money is going, if we take all money out of fossil fuels and we stick it, or out of the subsidized portion of fossil fuels, or whatever portion we're doing it at, we stick it into hydrogen, we still have this problem of creating CO2 emissions and not getting a ton of efficiency out of it. And we've shown that the way to increase that efficiency is to find some other renewable energy source. So really what we kind of have like a counter proposition, that instead of putting all that extra money directly into hydrogen, we'll distribute it evenly among the renewable energy sources. So that's hydro, geothermal, nuclear, solar, and wind. And to show that we have room for improvement in those areas, I have a couple quotes. This is from the U.S. Energy Information Administration. It says that conventionally, hydroelectric sources provide 6.4% of the total power generated in the U.S., while other miscellaneous energy sources generate the remaining 4.1% of electric power. We already said before that year-to-date, coal-fired plants contribute 45.3% of the power generated in the United States. So so we need to get off fossil fuels. We have a lot of room to go with using hydro and other sources. Let's see here. For example, Brazil, Canada, Norway, Paraguay, Switzerland, and Venezuela are the only countries in the world where the majority of the internal electric energy production is from hydroelectric power. Paraguay produces 100% of its electricity from hydroelectric dams and exports 90% of that to Brazil. That means that it is feasible for us to find a renewable power source that's not fossil fuels, and really come up with a solution for this. But that won't happen if the extra money that we're pulling out of the fossil fuel substation goes only into hydrogen. We need to also go into other sources.